Hello, good afternoon everyone. In the last week, we have seen the comparison of properties of the solid, liquid and gases. So in that we have seen that the particles in the solid that can be atoms or molecules. When we say a sodium element, the smallest particle will be the atoms. But when we say an example of a solid compound as sodium chloride, common salt, it is made up of smaller minute molecules, that is NaCl molecules. Next one, the intermolecular space. In case of solids, the intermolecular space is very less. The particles are very close to each other. And the interparticle force of attraction, or you can call it as the intermolecular force of attraction, is strongest. Therefore, they can move very little over here, just a fine distance. And therefore, they also have a very less kinetic energy, the least kinetic energy, solids. But when we say the liquids, that can be atoms or molecules, but the intermolecular space is more. Intermolecular space is more than the solids, and the interparticle force of attraction is little bit weaker than the solids, and therefore the particles can move a little bit more. Particles can move a little bit more, and their kinetic energy is also more. In case of gases, the molecules, the intermolecular space is very large. See, the particles are far away from each other. The intermolecular space is very large and they are loosely arranged. The intermolecular force of attraction between them is very weak. So as the intermolecular force of attraction is very weak, they are loosely arranged, they are loosely packed, and their kinetic energy is very high. They have the maximum kinetic energy, and therefore they can very easily move. They can very easily move. So this was about what we saw in the last lecture. Now, let us study some properties of matter. In that, the first one, size and shape. So as we have seen, in case of solids, the intermolecular space is minimum and interparticle force of attraction is the strongest. Therefore, they have a fixed size and fixed shape. And as the particles cannot move, their size and shape also does not change. But in case of liquids, the interparticle force of attraction is little bit weaker and the intermolecular space is more. Therefore, they can easily move from higher level to lower level. And also, they do not have a fixed shape. Therefore, they can take the shape of the container in which they are filled. But in case of gases, the intermolecular force of attraction is the weakest and intermolecular space is also very high. And therefore, these particles can move anywhere, anyhow, very easily. They can move very easily. The next property that we are going to see is the density. Density is mass per unit of volume. Mass per unit volume means in the given volume, how many particles are there. If there are more particles, the density will be higher. If there are less particles, the density will be less. So this density is mass per unit volume. As the number of particles in a smaller volume, in a smaller volume of solids is very much high. More particles are packed in a solid. They are very close to each other. Therefore, their density is highest. Solids have the highest density. And then the liquids, and then the gases. The gases, they have very negligible density. They are very lighter. Next one, we are going to see the change of state of matter. So, when the state of matter changes, when the state of matter changes, let us see some conditions for that. So due to heat, so solid material, when heat is supplied to it, it undergoes melting. It is converted into a liquid state. So what happens over there? To a solid particles, when heat is supplied, the particles gain the energy. Their particles start moving a little bit faster. Their kinetic energy increases. And therefore, as the kinetic energy increases, they move away from each other. And as they move away from each other, they change into a liquid state. And this phenomena of changing of solid into a liquid at a certain temperature is called as melting, which takes place when heat is supplied. So what happens over here? The particles, they break the interparticle force of attraction and they move away. They change into a liquid state, and this condition is called as the melting or fusion. At this stage, the solid undergoes a physical transformation into its liquid state, and this phenomenon is called as melting or fusion. Now boiling. When you are going to continue supply a heat, when you are going to continue supply heat to a solid material, the temperature rises very slowly. The temperature rises, and at this stage, the pressure of the liquid becomes equal to the atmospheric pressure. The liquid, what happens is when you start heating the liquid, when you start heating the liquid, the particles gain the energy, they are converted into a vapor state. They are converted into a vapor state. And so the vapor pressure of the liquid comes equal to the atmospheric pressure. The vapor pressure of the liquid becomes equal to the atmospheric pressure, and the particle level, the kinetic energy of the particles become large enough to overcome the interparticle attractive forces, and the liquid transforms into a gaseous state. Liquid gets converted into a gaseous state. The changing of liquid to a vapor, that is gaseous state, due to heating is called as the vaporization. It's called as vaporization, and vaporization takes place at the boiling point, called as the boiling. Vaporization, conversion of liquid into gas, is the vaporization, which takes place at a particular temperature, called as the boiling. At the same time, when you cool down the vapors, you are taking out the energy. When you take out the energy, the particles start coming together to each other. The vapor particles, they start becoming closer to each other, and when they become closer to each other, the random movement decreases, and now they are converted into a liquid state. So liquid state is formed, and this condition of conversion of vapors into a liquid state is called as condensation, which takes place at a fixed temperature called as the condensation point. Now, when you cool down the liquid particles, here the liquid particles are closer, but if you cool down them more, you are going to remove out that energy. And this process, when you remove out the energy, the particles start coming very close to each other, called as freezing. So liquid changes into a solid material at a fixed temperature, called as freezing, that is solidification. And the temperature at which this process of freezing occurs is called as the freezing point. So let us see the diagram. Ice, which is solid. When you heat it, particles move little bit away, liquid state. When you still heat it, vapors are formed. The particles are more away from each other at 100 degrees Celsius, vaporization. Now go reverse. Water vapors, when you condense them, they start coming closer and closer and closer. So what is formed? Liquid water. The particles are closer to each other. Their energy is less than that of the gaseous material. And when you still cool this liquid, that is water, at 0 degrees Celsius, it forms the solid. And their kinetic energy is the minimum. So this is about the change of state into solid to liquid, liquid to gas on heating. And when you reverse it, cool it, the vapors are converted into a liquid state and liquid into a solid state. And all such things takes place at a particular temperature. Next one, evaporation. The river water, sea water continuously undergoes evaporation. So what happens? Because of the heat energy of the sun, the river water is not boiled. There is no any gas down below the water to boil it, or the sea water to boil it. No, it's because of the heat energy of the sun from the top. So what happens? The particles which are present at the surface of the water, they get enough heat energy from the sun. So what happens? Their kinetic energy increases. And they easily move from the liquid state. They start moving into the gaseous state. From the liquid state, they start moving into a gaseous state. But this takes place at any temperature below the boiling point. And this phenomenon, in which a substance changes from liquid state to any gaseous state, at any temperature below the boiling point, is called as evaporation. So this evaporation is a surface phenomenon. It takes place at the surface of the liquid. But boiling, when you are boiling water at home in a container, you supply heat and boiling takes place from the bulk of the material, inside the material. Water from inside starts boiling. So boiling is a bulk phenomenon and your evaporation is a surface phenomenon. Boiling is a bulk phenomenon and evaporation is a surface phenomenon. Dear friends, factors affecting the rate of evaporation, when the rate is higher, when the rate is lower. Temperature. As the temperature increases, the kinetic energy of the particles increases, they move into a vapor state. And therefore, as the temperature is higher, the particles get more energy, they move into a gaseous state, and therefore the rate of evaporation is higher. So that is why when the temperature is higher in summer season, the clothes dry faster, they get more energy. The water droplets get more solar energy and therefore they get more energy. The kinetic energy increases and they evaporate fastly. Water droplets evaporate fastly and so the rate of evaporation also increases. Moisture or humidity, moisture or humidity. So what happens if a cloth is drying over here? If a cloth is drying, there is a lot of moisture present over here. So what is going to happen? Obviously, the temperature on the surface of this cloth is not going to rise fastly because of the moisture present, and therefore, the water droplets present on this cloth will not get the solar energy. Therefore, their kinetic energy will not increase. And therefore, the clothes will not dry. As the kinetic energy not increases, they will not go in the vapor state. And therefore, due to presence of moisture and humidity, the rate of evaporation decreases. And hence, clothes require a lot of time in the humid weather or the rainy weather to dry. Surface area. See here, a cloth on a string, it is spread out very nicely. The area is more. More area will be exposed to the sunlight, therefore evaporation will be more. But if the cloth is placed very compressed, the surface area will be less. Therefore, the particles will not get that solar energy to evaporate. The water droplets or the water particles, they will not get that much energy and therefore the rate of evaporation will be slower. Movement of air. See here, this cloth is drying. This cloth is drying and it is giving out vapors. And a cool air breezes just moves aside. It will carry the vapors very easily. Again, fresh surface of this material of cloth will be exposed. So what happens? Again, the air will come in contact and the vapors will be moved away. So what happens every time the cloth is exposed to sunlight, vapors are formed and being carried away by the movement of air. So what happens? The clothes will dry faster. And that is by one simple example, dear friends. Many a times when we are in a hurry, we dry our clothes under the fan, or the cooler. So what happens? The air carries away the water vapors very easily, very fastly, and therefore the clothes dry faster. So these are the four factors affecting the rate of evaporation. The same you can see on the videos that I have sent you. Sublimation, yes, the conversion of solid directly into a gaseous state is called as the sublimation. It does not go through the liquid state, and such substances are called as the sublimable substances or sublime substances. Example is your iodine crystals, ammonium chloride, camphor, white tablets of camphor that we keep in the corners of our room, naphthalene, yeah, camphor, which we burn daily for the puja, and naphthalene balls, which we use on our basins or the corners of the room. Then solid carbon dioxide and air fresheners. These are the sublimable substances. These are the sublimable substances. So what happens in sublimation? The solid substances absorb so much heat from the surrounding that they directly move into a gaseous state without going into a liquid state. Without going into a liquid state. Now, change of state due to pressure. So what happens when you apply pressure? When you apply pressure, also the particles can be compressed. The particles can be compressed. But in case of solids, the particles are very close to each other, so they cannot be compressed a lot. They cannot be compressed a lot. So under pressure also, the solids, they do not change their shape a lot. But when extremely high pressure is applied, At that time, you can change the shape of the solids. But liquids, on the other hand, they have large intermolecular spaces. Intermolecular space is large. So what happens? When you apply pressure, the particles come closer to each other and they can be easily compressed. So when a liquid, okay, when you apply pressure, it can be compressed, but not that much. It can be compressed very little. It can be compressed very liquid. On the other hand, gaseous particles very much far away from each other. When you apply pressure, they can be easily compressed. When you apply pressure, they can be easily compressed. And what happens when you compress these particles of gases? They come very close to each other under that pressure and they are converted into a liquid state. They are converted into a liquid state called as liquefaction. Example, LPG, liquefied petroleum gas, which is compressed in a liquid state in that cylinders. It is in a liquid state in that cylinder due to the pressure. In the same way, your CNG is also compressed in the form of liquid, but all these, they are under pressure. They are tremendous under pressure. Okay, so this is about the change of state due to pressure. Liquids can be compressed a little. Solids, they cannot be compressed very easily, but gases, they can be easily compressed because they are having large intermolecular spaces. Yes. Okay, friends. Yeah. Just I'll give you a break of 1 minute, dear friends. You can drink water. Yeah. You can drink water a little bit. You must have that habit of drinking water nowadays, a bit for that. Now, why the conditions for changing the states of matter differ? Why the conditions for change of states of matter differ? Now, see here, solids, they have different force of attraction and they require different amount of energy to be transferred into liquid. For every solid, they have different forces of attraction. Some solids, they have very high interparticle force of attraction. Some have a little bit less as compared to the first solid. And therefore, they require different kind of energy, different amount of energy to be transferred into a liquid state. The same is the case for the liquid state of matter, where the same is true for the liquid state of matter which gets converted into a gaseous state. They also require somewhat little amount of different energies. So solids and liquids, they require different amount of energy to be transferred into a other state of matter. Okay. Now, and the kinetic energies of the particles in different solids and different liquids are also different. The kinetic energies are also different. Not that so. See here, solids, they just move here, but still the kinetic energies are a little bit different. Okay. But in case of gases, the interparticle forces is very less, minimum. And the interparticle force of attraction, yes, the interparticle force of attraction is very less. But interparticle space is very high. And it is same mostly for all the gases. They have very high interparticle spaces and very least interparticle force of attraction, but they mainly differ in their kinetic energies. Some of them have very high kinetic energy, some of them have little bit less kinetic energy, and therefore they have the same interparticle force of attraction, negligible. Yeah, same interparticle force of attraction which is negligible, and interparticle space is also same, that is very high. All the gases, but they differ in their kinetic energy, and therefore these gases, they show almost the same identical behavior at a given temperature and pressure because of these three reasons: the same interparticle forces of attraction, the same interparticle spaces mostly but mainly differ in their kinetic energy, and therefore they show the identical state of behavior at the given temperature and pressure,